All right, thank you everyone for attending session 2A, Technology for and by Data Practitioners at the RDAP Summit 2023. Before we begin, I'm just going to go over a few things. This is a Zoom webinar. Attendees are muted and your cameras are turned off. To ask a question, please use the Q&A at the bottom of the screen. This particular session will run from 1:20 to 2:20 p.m. Eastern, with hopefully the last 15 minutes for questions and answers. The session will include 2 live presentations, followed by 2 pre-recorded lightning talks. You will be able to ask questions of all the presenters from both live and recorded talks at the end. When you put your questions into the Q&A, please make sure that you indicate the presenter or presenters you would like to direct your questions to, and we'll save all questions till the end of the session. After the session, please feel free to drop questions and continue the conversation in the chat in Whova. All right, and the Research Data Access and Preservation, RDAP Summit organizers, are committed to providing an environment where all attendees can participate fully in the program and activities without fear of harassment or discriminatory behavior of any kind. There is a code of contact helper available during this session. Tisha Mentnek, who is identified as a code of conduct helper in Whova, and you may direct messages to them in Whova if you need assistance. They can give you the code of conduct email address or the link to the incident report form if needed. All right, now that that is out of the way, we can go ahead and start our presentations. Our first presentation is Pearls and Pitfalls, a story of a programmatic data pool, given by Alicia Hoflick-Moore from the University of Minnesota, Wendy Kozlowski from Cornell University, and Shauna Taylor from the Association of Research Libraries. Shauna?
Okay, how does that look? Good.
Looks great.
Okay, thank you. Okay, so thank you everyone for joining us today. As mentioned, my name is Shauna Taylor and I'm the project manager for the NSF funded project, The Realities of Academic Data Sharing Initiative, based out of ARL. So you won't be hearing too much from me today, as Wendy and Alicia will be doing most of the presenting. But I do want to give a bit of context about the entire RAD study. We're looking sort of at 3 main things. So first, we're looking in depth at institutional and researcher activities that facilitate data sharing. We're looking at the cost of data sharing, as well as the quality and completeness of research data metadata. So Wendy and Alicia will be speaking to this latter piece of the RAD study and speaking to one of our research questions: where are researchers from our 6 participating RADS institutions sharing their research data, and what is the quality or completeness of the metadata, sort of with the RDAP theme of building on experience and centering communities as a guidepost to a very small section of something very large to answer that question. So with that, I'll turn it over to Alicia.
Thanks, Shauna. As Shauna mentioned, our main question in this analysis was, where's the data? Where are researchers from our institution sharing or publishing their research data? We wanted a systematic approach to this question to search data publications over the previous 10 years, which was a window between 2012 and 2022. We built on initial work done by Ted Haberman of Metadata Game Changers, who pulled summary level data about all DOIs from our institutions. But we as a research team had more questions than answers. So we did a bit more digging. We turned to the main DOI registration agencies in the US, which are Crossref and DataCite. Both have APIs, or application programming interfaces, that allow querying of their databases through code. And Crossref has a very large public use data set that ended up being a better fit for our questions. Okay, so this slide presents the path of narrowing our search through each of the DOI generating databases and the number of DOIs associated with each step. We filtered to select DOIs associated with our 6 institutions that were published on or after 2012, and that were identified as data sets in fields describing their types. Although I'll mainly be referring to these as data DOIs in the results I talk about, it's important to note that we also included software in this, which is only an option for specification in the data site metadata. So total, we resulted in 179,648 DOIs. Notably, about 5,000 of these were software. The rest were considered data. Which brings us to our first pearl or win of this project was the sheer number of data publications we were able to find. This graph on this slide shows the distribution of data DOIs across our 6 institutions, ranging from just over 2,000 to over 150,000 at the University of Michigan. This was such a large number that we had to split our axis, as you see on the slide, just to get all the bars to fit on the same page. We couldn't wait to dig in further. But a little more digging revealed our first pitfall. Because all of us were associated with DOI issuing data repositories at our institution, we expected to see our institutional repositories on the list of places where researchers were publishing. In fact, we knew just how many data sets were in each of our institutional repositories, but they weren't in the data. So for example, I knew at the time, Minnesota had 692 data sets in our data repository for the University of Minnesota, or DRUM, but we only found 90 of them. What was going on? Well, even though all of our institutional repositories serve researchers from our institutions, we do not enter all affiliation metadata into the data site metadata fields. Or Crossref, which is what Duke's repository was using at the time of this search. But because we built our search around values in the researcher affiliation field, unsurprisingly, of course, in hindsight, we didn't find DOIs from repositories that didn't have this metadata entered. But in this specific case, because we knew our repositories were places that researchers were putting data from institutions, and because this was really important to us and our institutions, the data we had, we did a second search for our repository names as publishers from our relevant DOI issuing agencies. So 5 of the 6 of us were DataCite, 1 was Crossref. We found an additional 2,164 DOIs. Okay, now we can get to the actual question of interest. Where is the data? So we found that researchers are publishing across 176 different publishers, but only 55 had more than 10 data DOIs associated with them. The graph on this slide shows the top 10 publishers on the y-axis with the proportions from each institution depicted by color. Our first response to this graph was, It brought even more questions, some about the nature of the repositories themselves. For example, what is this ENCODE data repository that is breaking the axes once again with over 130,000 data sets from Michigan? Well, it turns out it's a repository of genomic annotations and transcripts with a bulk of the DOIs generated from a single researcher in 2021. We also didn't know what Faculty Opinions LTD was. And so this appeared to be a journal of data or article reviews and not data at all, despite its tagging as a data type. We also had questions about the repositories we were familiar with. For example, we were surprised at how many data sets were published in Harvard Dataverse. We found that from each of our institutions, there were only a handful of researchers associated with these data sets, and that left us even more questions. So of course, we couldn't help ourselves and we did more digging. So we found that some repositories, such as Harvard Dataverse, were assigning DOIs to the individual files instead of to the study or the collection of files. So when we were comparing the number of DOIs from these repositories to repositories that issue 1 per study, they appeared to have much greater use. So in this slide, there's a screenshot of one example study in Harvard Dataverse that had nearly 2,500 files associated with it, each of these having their own DOI in addition to the study level DOI. So one of the things we did is to help equate repositories that assign file level versus study level DOIs, we refiltered the data to collapse all the DOIs associated with the same study. Okay, now where's the data? So after removing faculty LTD and combining DOIs from files with the same study, so we were comparing apples to apples, we were left with about 166,000 DOIs. So in this graph, the y-axis contains the top 10 repositories for this clean data. And you might notice the specific repository ranking shifted considerably, with Zenodo, Dryad, and our institutional repositories coming in as the most used after ENCODE. We were excited to finally have this data and report back to our institutions, but upon reflection, our takeaways were much less about what we found and much more centered on our reflections on how we found it, and importantly, what we didn't find. So for discussion on that, I will turn it over to Wendy.
Thanks. So now you know what we did, how we did it, and what we found. Let's talk about those assumptions and some of the bigger picture impacts. So the big elephant, I think, that is there is that we made a really big jump in saying that we were going to use DOIs as the identifier of choice for data and software. But was that wise? Is that really the case? So how many people actually know when DOIs really came into use? You can throw some numbers into chat if you want. Of course, I'm going to tell you, you can change this slide, Shauna. The concept of DOIs was conceived in 1997. Crossref was the first registration agency that actually pushed out DOIs en masse, and that didn't start until the year 2000. And they weren't actually accepted as a ISO standard until 2010. You can see in this figure from the DOI website, which is an API pull as of last night of the total number of DOIs, so it includes publishers and data sets, that the use of DOIs has indeed increased. And maybe we weren't that far off in saying that our repositories and current data practices all use DOIs as a PID of choice. But what about all those data sets that are down at that tail end? And what about the repositories, you can switch to the next slide, Shauna, that aren't issuing DOIs at all? And we lost that chunk of data in our research. So what are some of the other things that could be in use? Handles are still extensively used by a lot of systems, and locally managed identifiers such as ARCs are often very popular and still in use in a lot of different platforms. Alicia talked about the ENCODE data that does have some medical data or genetic data associated with it, but we did not use ascension numbers, which is the norm and the practice accepted by funders and other repositories for most medical data. So that was completely lost in our collection as well. And then, as I mentioned, there's a lot of other identifiers or a lot of other data sets that are out there that aren't using identifiers at all, much less registered identifiers. So humanities data, climate data, things that are shared on websites and via special collections that aren't using any kind of persistent identifiers. So if we then leave DOIs, whether or not DOIs was the right thing or not, and dig into actually how we use DOIs, that we found to be really important as well. So Alicia mentioned that our repositories in this study use two main registration agencies, DataCite and Crossref, but there are 10 other registration agencies out there issuing DOIs. Research is global, research is collaborative, and we made a really large assumption in saying that we were going to find all of our data by searching through just those two registration agencies. And as you might have guessed, we need to talk about this idea of metadata richness and the impact of how we fill out the fields associated with our DOIs and how that can impact the ultimate findability of that content. So for example, at Cornell, we have made a specific decision in our policy, or we made originally a decision to fill out a minimum amount of metadata with our DOIs. And that was because we wanted to be able to be sure that we can maintain properly those records. And not all data sets get DOIs in our repository. Some of our older content doesn't get them, as you might have guessed from that slide. We also touched on this issue of versioning and granularity and the impact and how different places are doing it differently. And the community hasn't come to a consistent place where we're all doing that the same. And that obviously is going to have a big impact on how the data, it looks to the final result of the data looked. I think a smaller but still relevant elephant in the room is around this issue of how we are addressing persistent identifiers and citation of code and software. There's a lot of code and software that is still being shared on platforms like GitHub, which is fabulous, but not necessarily being pushed out as a snapshot and put in a persistent place like Zenodo or any of our institutional repositories. So on the next slide. This is all to say that all of these things that we might be doing wrong are for good reasons. And there's reason, the struggle is very real, and metadata decisions that we make that have gotten us to this point were difficult and they were complicated, and they're often impacted by local policy and practice and whether or not we have the people and the money to make the changes and do things differently than we do right now. Many of us are dealing with multiple different kinds of standards. We heard that in the previous session about all the different metadata standards that are out there and in use for very good reasons. And when we find mistakes, it is also time consuming and takes a lot of personnel. And we need to make a decision about whether or not we can go back and correct our past mistakes, or if we need to put that capacity that we do have in the present and in our practices looking forward. So in this project, why did it make a difference? So we found that the way we did our search to find these data sets introduced bias in our results. Because of the way we filled out the information, we in our repositories filled out the information for the DOIs, we essentially were unable to find and therefore essentially lost the information from what was generally the smaller, less resourced repositories. And if we look on the next slide, why this matters in the bigger picture outside of just this project, the RADS group can't possibly be the only one doing this kind of research digging and pulling of data. Within our repository ecosystems, we can very much see where this data would be used for decision and policy making. It could be that administrators are interested in finding out this information to make decisions about whether or not they're going to build or purchase, whether they're going to just sustain or actually invest in, or maybe shut down data repositories. We want to make sure that we're providing correct information for these decision-making plans. DOI subscriptions cost money and personnel. Our institutions are tracking researcher output, and researchers themselves need to be able to discover the data in order to further their scholarship. So our project itself looked very closely at this affiliation field, but it did open our eyes to whether or not there are other problem fields in our metadata that could be causing bias. But to leave on a more positive note, we came up with three ideas of how we can reduce the impacts. We want to make sure that we review our practices as regularly as possible. And when we find mistakes, be willing to make changes and be willing to talk with our community about them. RDAP is a great forum for that. We also will need to be willing to talk about our practices and the problems that they cause with funder and policymakers in order to be able to enact change from the top down. Researchers, publishers, policymakers, everyone is getting pressure to create DOIs, but our practices have an impact and we need to be able to look at what is happening within the bigger picture based on that. And our last slide is just some contact information. We're, of course, happy to answer questions. Thank you.
All right, thank you for that. That was very interesting. Okay, so up next is the presentation titled Walk the Walk, Turning Research Data Theory into Practice Through Co-Authoring Health and Environmental Data Research. And this will be presented by Caitlin Throgmorton from Yale University. Caitlin?
Hi, thanks. Just double checking that you can see my screen. It looks like you can. Okay, great. Move another window here. All right, hello there. I'm Caitlin Throgmorton, data librarian for the health sciences at the Cushing Whitney Medical Library at Yale University, and I use she, her pronouns. I'd like to acknowledge that I'm on land owned and stewarded through the generations by Indigenous peoples and nations, including Mohegan, Mashantucket, Pequot, Eastern Pequot, Schaghticoke, Golden Hill, Pagusset, Niantic, and the Quinnipiac and other Algonquin-speaking peoples. I'm grateful to be here with you today at RDAP and want to thank RDAP's organizers for planning such a great conference. You can find these slides on Whova and on OSF at the link here, osf.io/B2UYG. Today, we're going to be talking about a data research project I've been working on with a clinician researcher and several other collaborators at Yale School of Medicine. This project encapsulates what I think is most exciting and most challenging about how data practitioners like you and me facilitate data access, management, and dissemination in our communities. One of the best things about this project is that it's given me the chance to walk the talk, as the title says here, and also code while wearing a green sweater, as the person in this image is. By walk the talk, I mean turning research data theories, aka many of the things that I tell researchers to do as best practice, into actual practice myself. It's been eye-opening, and it's also been mostly easier said than done. But first, for a bit of background to kind of introduce you to the project and how it got started. This collaboration began the way many things do in libraries, with a reference request. A new to Yale early career clinician researcher was referred to me by email, that's the notification icon, with questions about where to find and how to access data. Their request was a bit unusual because they were looking for environmental data, not health data, which is what I usually support. But I've always had an interest in where health and environment information intersects. And after a series of consultations where I started to get more involved, the researcher invited me to be a co-author on the project. Initially, my role was focused on finding data and literature to support the research, thus the image of a person looking at a book, and also bringing what I like to think of as the data librarian lens, which includes a commitment to access, a strong knowledge of data resources, and a focus on data documentation and management. Pictured here are a price tag labeled free, a data dashboard with a warning, and a cycle icon. So what exactly have we been researching? The fundamental research question that we've focused on so far is, what's the relationship between the risk of exposure to environmental hazards and the emergency preparedness of nursing homes? Our first two papers have examined nursing home exposure risk to wildfires and hurricanes and evaluated their emergency preparedness through analysis of their citations from federal agencies, which is why this image shows an exclamation point with fire, water, and wind icons on a laptop. This is included using data from the following open sources: nursing home data from the Centers for Medicare and Medicaid Services, or CMS, environmental data from the California Office of the State Fire Marshal, and the National Hurricane Center at the National Oceanic and Atmospheric Administration, plus a few other data sets, too many to list here, but they are in the papers, which will be in the references. So over the next few slides, I'll be sharing some of our results so far, as well as our successes and challenges in working with the data. So one of the first successes, particularly for me, but also a challenge, came in increasing my role beyond data and literature finding to getting really involved in the data processing. The lead researcher that I was working with had been using a mostly manual process in data and Excel, which was quite tedious and slow and was really taking a long time. And I ended up transforming this into a faster, more replicable process in Python and Jupyter Notebook. Originally, this was something we had planned to integrate into the project gradually over time. But again, in the interest of sharing our mistakes, After receiving a revision request for our first paper, I ended up doing this in just a few weeks, which was really challenging, but worth it, as we ended up reusing that same process to submit our next paper soon thereafter. So what did this data processing pipeline involve? So I have that illustrated here, and this was really my portion of the project and the research. We had about 5 data sets that needed to be merged together, some that don't necessarily naturally go together, like information about nursing homes and information about wildfires and hurricanes. And with that merged data, the lead researcher would go on to perform statistical analysis and geospatial visualization. So I did quite a bit of data cleaning for standardization, particularly for messy identifiers and various text columns. Also, multiple computed variables needed to be created to run the stats, such as summed and average columns, conversions from one unit to another. So I created those. For both reporting out in the papers and for various data transformations, we need to group and shape and analyze data, as well as eventually merge data together, often into one data set where each row represented a nursing home facility. And finally, because almost everything that we were using was open government data, I had to account for and deal with lots of missing data and prepare to report out on it for the papers and as asked by journals and reviewers. And also pictured here, we have a polished up diamond representing the data cleaning, a grid for the variable computations, some arrows for merging and grouping, and a highlighted question mark for the missing data. So what did this all result in? Here I'm showing you the main figures from the 2 papers that have come out so far. All of the processing work that I discussed on the previous slide went into the creation of these 2 images, which were made by the lead researcher in ArcGIS. In both images, the dots, blue on the left, yellow on the right, represent nursing homes. And in the left image, fire hazard severity zones are shown in yellow, orange, and red, representing moderate, high, or very high levels. And in the right image, storm surge inundation thresholds from hurricanes are shown from 2 feet to 8 feet or more, depending on the shade of blue. What our analysis revealed in both instances is that higher risk of environmental exposure doesn't necessarily lead to better emergency preparedness, as it in theory should. Unfortunately, I don't have enough time to really get into the bulk of our findings today, but if you're interested, both papers are in the references. I do want to highlight this one line in the first paper, though. The current analysis offers a model by which publicly accessible information can be applied to align nursing home emergency preparedness, inspection, and enforcement with the magnitude of wildfire risk to which they are exposed. For me, this was a huge success of the project, being able to actually model how to apply open data to real-world problems. As proud as I am of our work so far, we do still have some remaining challenges. Once data access, even the most open data isn't always easy to get to or understand. We send a lot of questions to CMS and other data providers. Data retrieval automation is something I'm working on streamlining in the hopes that we can eventually use mostly application programming interfaces or APIs for data retrieval. Data harmonization just continues to be a challenge, and I think it always will be. I never cease to be amazed by how poorly standardized data from supposedly the same source, the US government, is. Even with a solid data processing pipeline and multiple data cleaning methods, this is just, I think, always and will be a challenge. This last point, which I think our team has done well, I call it as a challenge because it requires a lot of communication and awareness. It's essential to ensuring that what happens in data processing produces what's needed for statistical analysis. Often these 2 sides of the process think pretty differently. Data curators and statisticians tend to have different ideas about structures and other things. So there's always a bit of back and forth here and a lot of documentation created to facilitate this. Okay, so now I'm really going to get into the bulk though of what I want to talk to you about and how this has really changed the way I think about things. And I really invite hearing how you've changed over the years in terms of how you've gone from theory to practice. So that's what I'm going to dive into here. When I was in grad school for library and information science, I was so convinced that data management could be accomplished with a really high degree of fastidiousness and fidelity. And I was pretty into the idea of keeping everything perfectly organized. Since assisting more researchers in this area and also now having done some of my own research, I realize most of us just don't have the time or the energy or enough funding and staffing for that level of intensity. Over the last year or so, I've become a proponent of good enough data management. A shout out here to my fellow Yale data librarian, Barbara Esty, who's here at RDAP, and for first exposing me to this phrase. I tend to think of good enough data management, much like the images here. In the first image on the left, we have a green plant and a green planter, and each of the plant's leaves are basically the same size and the same pattern, and it's all neatly contained in the planter box. On the right, we have a green plant and a striped orange and yellow planter, and the plant's leaves are lots of different sizes, and the vines are kind of all over the place. But notice that both plants appear healthy, and they're both still contained. They're still in the same planter box, even if the left one is a little more all over the place, a little messier. So at this point, I am the planter box on the right. I'm really okay with my data management being a little messy as long as it's still mostly under control. On this next one, when it comes to openly available data, my theory into practice has actually really been strengthened instead of softened a little bit like in the previous example. I was a believer even before I had tried to use it for research, but now I'm an even stronger proponent. So far, it's successfully powered 2 of our published papers in an emerging field and continues to power more of our research currently underway. It's particularly essential for our team, which is led by an early career researcher who doesn't really have a lot of funding just yet and doesn't have the budget to purchase expensive data sets. While open data can sometimes mean much more data processing work in terms of cleaning, merging, and other preparatory steps, after seeing it in action, I believe it's worth it. Pictured on the left is a green unlock padlock, and on the right, a green check and a blue shield. Okay, so with this one, I hope I don't step on too many toes here. I know how hard some of us have worked and continue to work on educating our users and audiences about the importance of the whole research data lifecycle. But for me, this one is a bit like my epiphany around data management. This can become too much about executing each step of the process in order and less about following the process where it leads. So I've learned to lean less on the theory of a nice cyclical research data lifecycle and more into the practice of an iterative nonlinear journey. Much like the images here, I see this less like arrows pointing into each other in a looped cycle and more like several paths, some overlapping and some not, some backtracking and going in circles for a while that all eventually lead to more or less the same place. This way of thinking is not only more inclusive of the many types and ways of doing research, it's also more realistic to what really happens out there in the world, those realities of academic data, if you will. This last space in which my theories are transforming, it's still evolving for me because of my respect and admiration for open data and open source, and also because we're living in a moment where sharing all the time is normalized and sometimes expected or required by your funder. I've been 100% on the side of sharing as much data, code, and other material as possible, just as soon as you possibly can. And while I strongly support this idea in principle still, overdoing it can lead to releasing information that's actually quite difficult to reuse. Deciding what's best to share can also be tricky when you're in the situation we were for this project, where you're reusing open data that's already available and shared on the web. So for us, our sharing path is likely going to come in the form of releasing a Python code package focused on processing Medicare data, which is a shift from what I had originally envisioned and thought we would do, a data paper, but we're still thinking through it. In general, my transformation here is that I've settled on a carefully packaged information, often released at intervals, as represented by the one green heart here, rather than the lots and lots on the left. Regardless of what we ultimately decide on in the context of the entire data practitioner field, I think there's a lot more room for discussion on how we navigate this and how we do it so that data reuse can be less arduous and positively incentivized. So finally, if you're feeling inspired to take on some collaborative data research or to transform some of your current data practice or both, I have a few implications and opportunities, suggestions for directions you could head in. So the first is consider getting involved or more involved if you're doing it already in research. There are so many potential insights to uncover from the multitude of data floating about in our world right now. And I think these projects need more data-focused people on board. We bring rich ideas about data management and structure and analysis and sharing and more. And I think especially for data librarians, we could be involved in more subject-focused research than we are at present. I know I'm coming at this from a place of support and privilege in the library and the librarianship niche that I work in. Not everyone who wants to do this can, but I encourage you if it speaks to you. Second, maybe research isn't your passion or something you can engage in right now, but I know many of us are educators in our communities. I want to encourage you here. We need more practical data education, especially for junior and first-gen researchers and those who may not consider themselves technical, to bring about more rigorous data research and to facilitate access to data. This is an area that my current collaborators felt was especially important. There could be so much more data education for researchers. They just don't get enough most of the time. Finally, just an encouragement to keep doing the great advocacy work I know many of us are doing for better data management, more open data access, better tools for working with data, better tools for finding data, and more critical data literacy. It's doing a lot of good, and I extended my thanks to the advocates before me. You're why I'm here and able to work on what I've talked about today. So cheers to you all working tirelessly today, yesterday, tomorrow, and often behind the scenes. And before I conclude, I want to thank and acknowledge the following people, especially Natalia Festa, leader of the research I've been talking about today, and a stellar colleague who couldn't be here today, as well as all of our co-authors, Tom Gill, Nora Heafy, and Maureen Canavan, and various others involved. I want to thank my library, the Cushing Whitney Medical, and especially the people listed here for their support in general, as well as particularly in helping me prepare for this talk. And finally, our references, which I welcome you to check out. That's it for me. Thank you again for your time, and I look forward to seeing you in the Q&A and elsewhere at the conference.
All right, thank you very much, Caitlin. That was very interesting. Okay, and so next up, we have our two lightning talks. First up will be Responsible AI in Libraries and Archives, Considering Our Values and Reducing Harms for Our Communities, presented by Doralyn Rossman from Montana State University. And the second lightning talk will be Digital Curation and VR, a discussion on Virtual Bethel, presented by Raneem Hijazi, Indiana University, Purdue University of Indianapolis.
Hello, I'm Doralyn Rossman, Dean of the Library at Montana State University. Today, I'm going to be talking to you about responsible AI, or artificial intelligence, tools for value-driven AI in libraries and archives. This is an IMLS grant-funded project, and today I will cover our initial findings, talk about the release, our case study template, and then give you some future directions and calls for interest with possible participation from the RDAP community. The motivation for this project revolves around how AI is becoming more common across all sectors, including higher education, and within that, including archives and libraries. So how can we use AI to improve services while also upholding our values and protecting our communities from harm? The goals of the project include developing practical resources that support responsible use of AI in library and archives contexts. And ultimately, these resources will help libraries and archives practitioners consider ethical implications as they embark on new AI projects that support increased impact and new uses of library resources. AI is a rapidly emerging field, as we've seen with ChatGPT, and it's really important to keep in mind things like through the slow and careful adoption of tech, the library can be a leader. Let's not just jump into this, but let's be thoughtful and keep ethics in mind. This is a multi-phase project, and we've completed the first phase, which included a literature review and a call for participation with case studies. And then we are going to be conducting some workshops this fall, developing a harms analysis tool that will include feedback from our user community. We'll conduct assessment and validation of that tool, and then ultimately develop a final version of the tool and a handbook. Phase 1 included an environmental scan where we searched databases and conference proceedings using certain keywords. We identified 165 articles touching on AI and 77 case studies that we can analyze. We identified the literature and broke it into 6 different types. Those were dominated by academic libraries, large size institutions, regional representation across the United States and Canada, types of materials discussed, and technical and practical tags that were used. And finally, different kinds of ethical concerns raised. In these spaces, we found that only 77 of the case studies had 15 of those with ethical concerns raised. And most of the concerns were raised were more about technical and practical issues rather than the ethical challenges. Phase 2 included a call for proposals for case studies, which are due in May, and ultimately they will appear in a special issue of JESLib in winter, spring 23-24. We will put a call out to the community to add to this journal issue, so keep an eye out for participation. The case studies that we have include 8 different teams with various subject matter covered, and we will be providing updates to those at this URL. Our ethical considerations include these questions that are part of our case study, which are linked down below here in the slides. And again, you can find those at our project update page. In phase 3, we'll be conducting workshops, trying out our harms analysis tool, and again, publishing in the special issue of JESLib. Our project team is led by Sarah Mannheimer at Montana State University, along with our partners also at MSU, at Iowa State University, and James Madison University. Our project advisory board members are listed here. We also invite you to visit the grant award page to find out more about this grant. And finally, feel free to contact me or any member of the project team with questions, comments, or concerns. And we hope to see participation from the RDAP community, as AI is very present in the data part of our lives as well. Thank you for your time.
Hello, everybody. My name is Raneem Hijazi. I am an MLIS student at IUPUI, and welcome to my talk on digital curation in VR, a discussion on Virtual Bethel. So what exactly is Virtual Bethel? Virtual Bethel is a virtual reality experience of the Bethel African Episcopal Church of Indianapolis, which is a church with an extensive history within the African American community of Indianapolis. The virtual reality experience itself holds a 3D interactive landscape of the interior of the church, as well as cultural heritage materials narrated by key figures within the African American community. This experience was made in collaboration with the IUPUI Luddy School of Informatics faculty, students and staff, of librarians and 3D modelers, with discussion facilitated by Wilma Moore, a prominent African American history historian and Indiana history historian. The experience itself was created after the church was sold due to financial hardships, and community members were looking to preserve the cultural landmark for future generations of the African American community of Indianapolis. So what's so unique about Virtual Bethel? Virtual Bethel is unique in 2 folds. Number 1, Virtual Bethel is a community engaged project, meaning that the Luddy team really sought after the feedback from the community and asked for their input on the experience. So this project as a core serves a specific purpose to a specific community. Number 2 is that virtual reality itself is being used as a tool for the preservation of cultural heritage material. This is especially unique in that there isn't really a lot of precedence. So really the documentation process of what goes into making a VR experience is important for other researchers who wish to pursue this specific type of preservation. So onto the digital curation process itself. While working at the Digital Scholarship Center in the University Library with research data librarian Heather Coates, we received a variety of screenshots from the original team about the file structure so we can ensure the organization of the files. With VR, it's important that all the files are in the proper folders so that the experience can run properly. And we had to ensure the file structure matched after the university storage migration happened from Google Drive to OneDrive. And we needed to make sure all the files are in the correct locations and that everything worked for the experience to work. Number two is step two was building the documentation. We, of course, created a README for core information about the data, but we also created a getting started guide, which included context of the project, the information about the files, the information about the production process, the information about how to access the experience, and other supplementary information. And we uploaded the getting started guide to DataWorks in addition to the README so that people can understand the context and they can understand the production process. So then we communicated with the stakeholders by reaching out to the librarian and 3D modeler teams, and we asked them any outstanding questions we had about the project as a whole that we needed answered on our Getting Started guide. And it was quite an iterative process that lasted around a year and a half. And the team themselves were commenting, and we implemented their requests and edits into the Getting Started guide. Step 4 was the actual uploading to DataWorks. As of now, the experience is fully uploaded to the repository, but the manual ingestion was actually back end. And we had to reach out to the IT professional in the library to request manual ingestion. Now we're working on assigning metadata and keywords to ensure findability. So what exactly does this mean for research data? The specific context of the file themselves are the data, but also so is the documentation, because something like this has never really happened before, and that virtual reality is used for cultural preservation, and that we uploaded this to a data repository site, which is DataWorks. So the context is necessary for understanding the cultural heritage research data, which we try to emulate through the Getting Started guide. The preservation efforts in the digital sphere using VR, in this case, the process, is as important as the experience. Like I said, the description of the process and tools allows for best practice to be established in the field, because something like this is a novel idea within the preservation field. So in conclusion, when working with a community's heritage, it's important to provide context to the community's history, of course, to respectfully display that community's history. So some personal challenges that arose for me personally, the issues in communication, because of the long process, it meant constantly reorienting yourself with the content over a span of a year. So that took a time in and of itself. And personally, this is my first introduction to data curation and library sciences. My background was actually in art and social media marketing. So I didn't really understand the necessity of data curation and library sciences, especially in regards to cultural heritage. And personally, I am very invested in preservation of cultural heritage as a Palestinian who is looking forward to preserve their own culture. So this was an invaluable experience, understanding how data can be used as cultural heritage and how data can be used to disseminate information and preserve information. You can access the experience through these two links. The DataWorks link has the Getting Started guide that you can look into. Feel free to connect with me on LinkedIn. Thank you so much, and I hope you all have a great day.
All right, thank you all. And it looks like our time is just about up. So thank you to our presenters, and thank you to all of the audience for participating in this session. And so now we are going to move into a break until 2:45, and then there will be the opening keynote at 2:45, and just want to make sure everyone notes that there will be a new Zoom link for the keynote, and you can find that in the Whova agenda. All right, so I hope everyone has a good afternoon. Bye.